Okay, guys, so let's just get to it. We're going to go through the whole review on graphing sine and cosine waves with amplitude, period, and vertical shifts. And I'm just going to go ahead and put everything on one video, and if you need to find specific things, just scroll and find it. Okay. All right, so on this first one, it says -2 cosine of x over 8 plus 4. So the first thing I always do is draw my vertical shift and my amplitude. I know that my vertical shift is up 4, so 1, 2, 3, 4. So I draw my midline. And then my amplitude is the 2, so I'm going to go 2 up from my midline and draw my amplitude line, and go down 2 from my midline and draw my amplitude line. So I've got my max and my min delineated, and then I need to find the period of the wave. Keep in mind that all sinusoidal, sine and cosine, functions have these things going on, where A is the amplitude, the plus D at the end is the vertical shift, and the B right there has to do with the horizontal stretching and compressing of a function, and in this case we describe that using period. So we say 2 pi divided by B is the period, let me spell that correctly, of your wave. Okay? So in this case, B is the number in front of x, and so if I were to rewrite this, -2 cosine of 1/8 x plus 4, then I can clearly see that B is 1/8. So if I want to find the period, I divide 2 pi by B, 1/8. And dividing by 1/8 is the same thing as multiplying by its reciprocal, 8 over 1. And 2 pi times 8 is 16 pi. So in questions 1 through 4, the prompt is to graph 2 periods of the following functions and label the x-coordinates. So what I need you to do is make sure that you graph 2 periods, and I want you to use the whole wave, or the whole graph. I gave you 4 on this side and 4 on that side so that you could specifically say the period is 16 pi, so I'm going to let the end be 16 pi, which is the period. And then you need to label all the tick marks, right? Well, what you can do is say, well, this is 4 spaces between 0 and 16 pi. So you could just divide 16 pi by 4 to get the first one and then add. Or you could just start cutting in half. Half of 16 pi is 8 pi, and half of 8 pi is 4 pi. So I know every time I'm going 4 pi. 4 pi plus another 4 pi is 8 pi plus another 4 pi is 12 pi. I did say label all the x, so let's go backwards. -4 pi, -8 pi, -12 pi, and -16 pi. Okay? So the only other thing to do is to, because I know what the period is, I know all of that. I just need to know what kind of graph I'm going to be drawing. And it is a negative cosine wave. So for a negative cosine wave, out to the side, I'm just going to draw a little negative cosine wave. And then think about the points. You've got this point, that point, the max, the center, and back at the midline, or back at the minimum. The end should be at 16 pi. So I know I should start at 0 at the minimum. I should end at 16 pi back at the minimum. Halfway between 0 and 16 pi, I should be at the maximum, so that's at 8 pi. And then halfway between the min and the max, the mins and the max, I should be at the midline. And then my wave repeats itself over here. So if I were to connect these, remember, I don't know how much Heinz has been telling you, and I don't know if he's going to care as much, but if I see just V's, I'm not going to give you full credit. You're going to get something knocked off. These need to for sure be maxes, and these need to for sure be mins. If you draw anything like that, that's going to get you points knocked off. Okay, so we got that on that side. And then just continue the wave, okay? So if it does this, then it needs to come back up to the midline, to the max, to the midline, to the min. Okay? So then we just continue. You know, and don't be afraid to go over it more than one time. It's the people that only graph it with one continuous line that usually end up having a mistake somewhere. I want to make sure that you go to the minimum, that you go through the midline at specific points, and that you go all the way up to the max. Okay? And so there's my first graph. Okay. On number 2. I have a sine wave. It's got a theta. Theta is the same thing as x. It's just got a theta instead of an x. It's just another variable. Okay? But I do have a -3, which means my midline is down here at -3 because that's my vertical shift. And then there's not a number in the front of sine other than just an understood 1, which implies that my amplitude is just 1. So I'm going to go down 1 and up 1 from my midline, and those are my amplitude lines. Okay? I need to find my period in order to be able to graph the wave to determine what the tick mark should equal. So remember, just like this one was 1/8, this one is 1/3 of theta. So the formula for period is 2 pi divided by b, which is 1/3. And dividing by 1/3 is the same thing as multiplying by 3. And so 2 pi times 3 equals 6 pi. So I'm going to go ahead and label the end as 6 pi. Okay, and remember, like I said, you could just take 6 pi and divide it by 4 to find this first tick mark. And 6 pi divided by 4 is 3/2. Okay? Or you could do this. Half of 6 pi is 3 pi, and then half of 3 pi is 3 pi divided by 2. Okay? Now, I need this point right here, though, right? So remember, this is 3 pi over 2. So if this right here, I got 3 pi over 2 plus 3 pi over 2, that is 6 pi over 2. So if I were to add that, then I would say that right there adds up to 6 pi over 2, right? If I then add another 3 pi over 2 to get to that one, then that all adds up to 3 pi over 2 plus 3 pi over 2 plus 3 pi over 2. You only add the numerators. That is 9 pi over 2. So that, and 9 pi over 2 doesn't simplify, so there we go. And then plus another 3 pi over 2, just to see if it makes sense. 3 plus 3 plus 3 plus 3 is 12 pi over 2 for the whole thing. And 12 divided by 2 is 6. So we know we're good. Okay? So then that means that's at -3 pi over 2. That's at -3 pi. -9 pi over 2. And -6 pi. Okay. We're graphing a positive sine wave. So a positive sine wave starts at the center, goes up, goes to the midline, goes down, and back to the midline. So you've got these 5 points. The starting at the midline, and the period is 6 pi, so that should be 6 pi, so there I should be there. And 6 pi should be back in the midline. At 3 pi, I should be at the center again. And then I know halfway between 0 and 3 pi I should be at the max, and halfway between 3 pi and 6 pi I should be at the min. Okay? And then we just keep the wave going. So, minimum, midline, max, midline. And then just connect. Now, some people have found it to be more helpful if they turn it sideways and connect it this way. And so you just kind of do this, which I'm okay with. I mean, whatever it takes for you to be able to graph it well. But you need to make sure that you go all the way to the max, the amplitude lines, and then go through the right points. Okay? Okay, the video is kind of, it's being kind of, okay, I think I'm back. Okay, so on that one, we're able to see 2 complete sine waves, one right here, and then the other one on the negative side. I don't know what it's doing. Okay, well, I'm going to keep going, and then if it gets really bad, then I might just start over. Okay, on this one, we have an amplitude of 4. We've got an 8 in front of theta, which is going to affect my period, and then there is no vertical shift. There's no vertical shift, then I know that my midline is at the x-axis. Okay? And then my amplitude is 4, the number in front, so 1, 2, 3, 4. I'm drawing my amplitude line. And down for 1, 2, 3, 4. Okay. I need to figure out the period of the wave to know what I'm going to label my x-axis. So the period is 2 pi divided by b, and b is 8. So 2 and 8 simplify down to 1 and 4. So the period of my wave is pi over 4. Okay? Now, on this one, you notice how we went 4 to the right and 4 to the left. But here we went 8 to the right. So if I need to see two periods, it makes sense to cut it in half. So each half is one wave. So that means we want to let halfway through be one wave. So I'm going to label that as pi over 4. Now, you do have to label the rest, so we're going to go ahead and talk about that. You could divide pi over 4 by 4 and get the first tick mark, or you could think this. Half of a fourth is an eighth, and you can figure that out by just saying pi over 4 cut in half. If you divide something by 2, that's the same thing as writing 2 over 1. And if you divide by a fraction, we flip and multiply. Those cancel out, and that's pi over 8. So cutting something in half is just basically multiplying the denominator by 2. Okay? So then half of an eighth is 8 times 2 is 16, so pi over 16. So if I want to find the rest of the tick marks, then I'm going to do this. This is 1/16, and so then another 16th, so 1/16 pi plus another pi over 16 is 2 pi over 16, which simplifies down to 1/8, which makes sense with what we just had. And then if I add another pi over 16, then I have 3 pi over 16, which does not simplify, which makes that 4 pi over 16, which does simplify to 1/4, which makes that 5 pi over 16, which does not. Now this is going to be 6 pi over 16, so at this point you can just count. And 6 and 16 both divide by 2, so 3 pi over 8. And then this one is 7 pi over 16. So basically I'm just counting 16ths. 1/16, 2/16, 3/16, 4/16, and so on. And then 8 pi over 16 is going to be pi over 2, which makes sense because a fourth pi is half of a half pi. Okay? Alright. Now I am graphing a positive cosine wave, and I know that cosine waves start at the max, go through the midline, hit a minimum, go through the midline, and go back to the max. And the end of my wave should be pi over 4. So I'm going to go to pi over 4 and plot a point at the max. And I'm going to go to the beginning and plot a max at the 0. And I know that halfway between 0 and pi over 4 should be at the minimum. And I should be at the zeros, or the midline, I should say, between those two. You should see two waves, so it just continues itself. It went up, so it goes back down to the minimum, to the center, and then back to the max. And then we connect. What I don't want to see is a bunch of V's, but at the same time, I know that your graphs are not necessarily going to be as curvy as mine, and that's okay. As long as you attempt to make sure I know that that's going to a max up there, and that is hitting a minimum right there. Okay, so max and mins. I should be convinced if you go straight to it like that, it's going to be a no-go. I got to be convinced that you would be able to create a max right there and then go back down if you needed to. Okay, so I at least got to have that. Okay. On number 4. Like I said, I always look for vertical shift and amplitude first. It says +1, so I'm going to go up 1 and draw my midline. And then the amplitude is a 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Okay. Now, I said the amplitude was 6. I didn't say it was -6, and that's for a reason. The negative doesn't have to do with amplitude. Amplitude is going to be positive and negative no matter what. The negative has to do with the wave, right? So a negative sine wave starts at the center, but then instead of going up, it goes down, goes back to the center, goes up, and then goes back to the center, the midline, okay? I need to figure out what that period is so I can label my x-axis. So 2 pi divided by b. And in this case, b is 6/5. So if I divide 2 pi by 6/5, that's the same thing as multiplying by 5/6 on top and bottom. 2 pi times 5, 2 pi times 5/6, you could say 10/6 pi, or you can say 2 and 6 simplified under 1/3. So that means the period of my wave is 5 pi over 30. Okay? Alright, so I'm going to label this to the right as 5 pi over 30. And then I need to find out all the other tick marks, okay? So half of 5 pi over 30, and remember, cutting something in half is the same thing as just multiplying by 1/2, okay? So dividing it by 2 is the same thing as multiplying by half. 5 pi over 3 times 1/2 is 5 pi over 6. So this is 5 pi over 6. And we're just multiplying the denominator by 2. So then half of 5 pi over 6 is 5 pi over 12. And then once you have the first tick mark, you can just add. So on this one, 5/12 plus another 5/12 is, remember, you just add the numerators when you're adding fractions. So 10 pi over 12. And that is going to be that one right there. And 10 pi over 12 is 5/6. If I add another 5 pi over 12 to get to this one, that's 5 pi plus 5 pi plus 5 pi. That's 15 pi over 12, which does simplify by 3. So that's 5 and that's 4. So that is 5/4 pi. And then we know 5/3. Okay? So I'm going to graph going the other way now. Or label going the other way. Negative 5 pi over 12. Negative 5 pi over 6. Negative 5 pi over 4. And negative 5 pi over 30. Okay. Now, we have a negative cosine wave. Or sorry, a negative sine wave. A negative sine wave starts at the midline, ends at the midline at the end of the period, 5 pi over 30. Halfway through, it should be back at the midline, but because it's negative, it should go down first to the minimum, and then max second. So this side should look like this. Okay, and now I need to go to the other side. So just continue the wave. I'm going to go, and you can, if you want to, just sketch it out over here, you know, go up and then come down and then do that. And then you could think about your waves that way. But I just continue the wave. So it goes up, midline, goes down, and midline. And there we go. I'm not going to count off someone if they, or count points off on someone if they did multiple lines like what I'm doing. That's perfectly fine. And in fact, you're more, it seems like it's more accurate then because you know that you're actually going through the points with that thicker line. Okay? Alright. Now, the next set of graphs is where you no longer are asked to just graph two periods. You're asked to graph given a certain window and given a certain scale. So it's a little bit more involved as far as finding everything. Okay, so let's just go ahead and draw midline and amplitude. Midline is up 3, so 1, 2, 3. Amplitude is 1, so down 1 and up 1. And I'm getting those from the number right here and the number right there. And then the number in front of theta is just 1, which implies that the period is 2 pi divided by 1, which is just 2 pi. Okay? So I can't just label 2 pi anywhere. I've got to label according to the this direction right here, 1 tick mark. Okay? So it's telling me that one tick mark is pi over 4. So that is 1/4 pi. And then I need to go ahead and label the rest because I need to graph from negative pi to 3/2 pi. So a couple different ways to think about that. If that is 1/4 of pi, it kind of makes sense that 1, 2, 3, 4 of them is pi. Or you can just go ahead and add. 1/4 pi plus 1/4 pi is 2/4 pi, which simplifies down to 1/2. So that's 1/4, 2/4, that's 3/4. This is 4/4 pi, which makes this 5/4 pi. And then if that's 5/4, then this is 6/4. And 6/4 simplifies down to 3 pi over 2, which is what we need to graph to on the right. Yeah. On the left, we need to graph to negative pi. So if positive pi is 4 to the right, then negative pi is 4 to the left. 1, 2, 3, 4. So this is negative pi. I tend to scale, draw my scale on the. I should have addressed this earlier, but I draw on the bottom because it leaves you a lot more space up here, and there's less confusion. So if you just scale it down here, then it's a lot easier to see. Okay, so I'm going to sketch a little sine wave. It is a sine. It's a positive sine wave. Positive sine waves start here, go up, come down, and then back to the midline. And that is 2 pi. And if the end of the period is 2 pi, then half of it is pi. So here's what I know. I know that I start at 0 at the midline, and then at pi I should be back at the midline, right there. And I know that halfway between 0 and pi, I should be at the max, right? So though I have these labeled, I don't need to put points at them. I mean, there are points, but they're not one of the main 5, okay? And if every 2 tick marks is 1/4 of the wave, then to get to 3 pi over 2 means to go to the minimum. And so I just keep the wave going on the other side. I need to graph to negative pi, which means if I go 2 tick marks over to get to the max, I go 2 to get to the min, and then back to the midline, and that is as much as the wave as we're going to see. And there you go. Okay. All right, on number 6. I need to graph from negative 3/2 pi to positive 3/2 pi. And when I made this, I don't know what I was thinking, but that I went ahead and changed for my classes for pi to pi over 2. So I don't know if Mr. Hines did that with you, but if he didn't, then you could, if you wanted to. What it ends up being is that you have very skinny waves. But I want to go ahead and change it to pi over 2 to make it a little bit more reasonable. Okay, so there is no vertical shift. We're not going up or down any, and the amplitude is 5/2. So I'm going to go, my midline is at 0, and my amplitude is 5/2, and 5 divided by 2 is 2.5. So 1, 2 1/2. Now, if it's 2.5 and then yours is like way up at the top of the wave, you got to make some kind of effort, okay? So make some kind of effort to make sure it's kind of in the middle. 1, 2 1/2 down. Okay. It is a cosine wave, and it's a negative cosine wave. I'm just going to do things in random order. I know I'm going to do them all. So. Here's my little sketch. Okay. I can figure out the period of the wave. It's 2 pi divided by b, and b is, in this case, 2. So 2 pi divided by 2 is pi. So I can go ahead and label that as pi. And then I said let every tick mark be pi over 2. So then this right here, I'm going to label it as pi over 2. So if that's half of pi, then that makes sense that that's pi. Okay? So if that's 1/2, then that's 2/2, which makes that 3/2. And if that's positive 3/2, then 1, 2, that's negative 3/2 right there. Okay, as long as I have the window that I know I'm going to draw in. Now I know some people do this. Once you find out your window, you just go ahead and mark those out so that you don't graph on them, and there's nothing wrong with that. That's perfectly fine. It's a good way to make sure that you don't go too far to the left or to the right, so that you only graph on the given window. Okay, you are supposed to sketch the negative cosine wave between 0 and pi. So, let's do... Okay. A 0, I know for a negative cosine wave, I need to be at the minimum. And at the end of the period, I should be back at the minimum, which is at pi. Okay? I know that halfway between 0 and pi, I should be at the maximum. And then I know that the wave should cross halfway between this and this. I have some people that just kind of sketch. That's not very good enough, or it's not very good. I would very much advise for you to put a point here and a point there. You're more likely to actually go through the center if you put points there. So max and min go down. Okay. And then, so that means every tick mark is half of a wave. So I've got one more tick mark to go. So then I know that I'm going to go, I'm just going to basically repeat that over there. And so it does this, and then it goes up. Okay. I need to graph the same thing on the left, which means just go backwards. So I knew the period starts there, ends there, max out in the middle, cross halfway. Cross halfway, max out. And there you go. Okay. Let's move on to number 7. Okay. Number 7 is a positive cosine wave with an amplitude of 4, and it shifts down 1. So I'm going to go down 1 and draw my midline. And then it says an amplitude of 4, so I'm going to go down 4, 1, 2, 3, 4. Draw my amplitude line, 1, 2, 3, 4. Draw my other amplitude line. I need to figure out the period. 2 pi divided by, that's bad. 2 pi divided by the number in front of x, which is, in this case, 1/2. And dividing by 1/2 is the same thing as multiplying by 2. So 2 pi times 2 is 4 pi. Okay, it's a cosine wave, and I know cosine waves start like this, and then they go back up to the top. And we're going to label that as 4 pi. Okay. Now, I need to make sure that I know what window I'm graphing on from negative 2 pi to 4 pi, and that one tick mark is pi over 3. So I'm going to go ahead and label my first tick mark as pi over 3. Now, a couple different ways to do this. You can start counting by thirds, 1/3, 2/3, 3/3, 4/3, 5/3, and keep going. Or you can use the fact that if that's 1/3 of pi, then 3 tick marks, 1, 2, 3, is pi. And if that's pi, then that means 3 more tick marks, 1, 2, 3, is 2 pi, 1, 2, 3 is 3 pi, 1, 2, 3 is 4 pi. And the reason I know that I can get away with just graphing the pi's is because I know the period is 4 pi, so that's broken up by pi's, and then this I'm only graphing to 4 pi. Now on the left I'm going to negative 2 pi, so 2 pi is to the right 6, so I'm going to go to the left 6. 1, 2, here's negative pi. 1, 2, here's negative 2 pi. Okay, so we've got a positive cosine wave that I know starts at the max at 0 and ends at the max at 4 pi. So go to 4 pi and be at the max. Halfway I should be at the minimum, which is at 2 pi, and then halfway between 0 and 2 pi should be at the midline, so at pi and at 3 pi. And then I'll just go ahead and connect. And then we're just going to continue the wave until I get to negative 2 pi. Now, positive 2 pi is half of a wave, so then negative 2 pi is just going to be the other half of the wave. So I need to midline at negative pi and minimum at negative 2 pi. Okay, and there's your function. Okay, number 8. Number 8 has a negative sine wave, no midline, and an amplitude of 4. So I'm going to go ahead and draw, I'm going to bold my x-axis for my midline, and 1, 2, 3, 4 for my amplitude. 1, 2, 3, 4. I'm going to go ahead and figure out the period of my wave. 2 pi divided by, in this case, 1/5. And dividing by 1/5, same thing as multiplying by 5. So 2 pi times 5 is 10 pi. So the period of my wave is 10 pi. I'm going to go ahead and sketch a negative sine wave. Negative sine starts at the center, goes down, back to the center, goes up, back to the center. And that's not symmetrical, but it will. So that is 10 pi. Okay. 1 tick mark is 5 pi over 4. So that is 5/4 pi. And like I said, one way to think about this is that that is a fourth of 5 pi. So 1, 2, 3, 4 should be 5 pi. But you could get that by adding. Okay. If this is 1 5 pi over 4, then this is another one. So we add 5 pi over 4. 5 pi over 4 plus 5 pi over 4 is 10 pi over 4. And 10 pi over 4 simplifies to 5 halves. Which makes sense if you think about this being 5 halves, that's half of it. And that's a fourth of it. So that should be 3/4 of it. So I add another 5 pi over 4 to get to that one. And that makes it 15 pi over 4, which does not simplify. But I could also get by multiplying 3/4 times 5 pi. And then plus another 5 pi over 4 to get to that one if you don't already have it, and that is 20 pi over 4, and 20 divided by 4 is 5. Okay? Now I need to graph from 5 halves pi up to 5 halves pi, and then all the way down to negative 5 pi. So positive 5 pi was 4 over, and the negative 5 pi is 4 to the left. There's negative 5 pi. Okay. But on my graph of my little sine wave, I noticed that the period is 10 pi. So the end of my wave is 10 pi, but I don't see that on there. That's okay. Half of it is 5 pi. So I know that I should start at the midline. I should be back at the midline for 5 pi. And then I should be at the minimum halfway between those. Except for, I'm not actually graphing that because that's not what I was asked to do. Okay, so I know 5 pi is right there, which means I know that that is halfway, so that right there. So I know on the right-hand side, that's all I see. Now on the left-hand side, like I said, if you want to continue the wave and label a negative 10 pi, you can. So that's negative 10 pi, which makes that negative 5 pi. And if that's negative 5 pi, then you know you should end at 5 pi. It should be at the midline, and you should have a max in between. Right there. And so you should only see this much of your wave. Half of it on the left and a quarter of it on the right. Okay? Alright, and let's go to this one. Okay, on this one we have a midline or a vertical shift of -1, so midline at -1. We have an amplitude of 0.75. If you break this down into half and then quarters, then you can kind of see where the midline would be. Okay. And then 1 tick mark is pi. So this is pi, this is negative pi, and that's negative 2 pi. But we're only supposed to graph from an 1/8 pi to negative 3/4 pi, or from negative 3/4 pi to an 1/8. Okay, negative 3/4 pi is further away. So I'm going to go ahead and graph on this side. If it makes more sense for you to graph to the right first, then that's what you could do. But I'm going to go ahead and explain it over here. So here's what I know. I know that half of negative pi, somewhere right there, is a negative half pi. And I know that half of a half is a fourth. So negative 1/4 is right there. And then if I count by fourths, that's 1/4, 2/4. That is a negative 3/4 pi, which is how far to the left I need to graph. Yeah? So that is a negative 3 pi over 4, and that is a negative pi over 4. Okay. Now, what I also know is that I could, instead of breaking this up into fourths, I could break it up into eighths, which that kind of implies that I need to. So if I think about this, I'm going to draw with a different color, those right there. And so you can see how we can think of this as eighths. So 1, 2, 3, 4, 5, 6, 7, 8. So I've broken it up into eighths. Okay, so, and that makes sense because half of a fourth is an eighth. Okay, so if I were to break up this side, there's a half right there. There's 1/4, there's 3/4, which means there's an eighth, 3/8, 5/8, and 7/8. So that is positive pi over 8. Okay. As far as graphing my wave, I know that it's a sine wave. So sine does this on the left, or on the right, sorry, and this on the left. And I also know that the period is 2 pi divided by the number in front of x, which is 4, which simplifies down to pi over 2. So the period is pi over 2. Okay, so that means that right there is a negative pi over 2. That is the end of my wave, right? So here's what I know when I'm graphing. I know that I should start, and actually I'm going to go ahead and label these points up here to make it easier. I'm not going to label, but I'm going to draw tick marks. Okay. I know that I should be at 0, I should be at the 0. At negative half pi, I should be at the end of my wave at the midline. Halfway through there, which is a negative 1/4 pi, I should be back at the midline. And the halfway between the midline, or the halfway point and the beginning is the minimum. And then I should be at the maximum at the negative 3/8. Okay, so I have a very small wave. And it does this. Okay, now if I have one wave between 0 and a half, then I should have another wave between a half and a pi. But I only want you to graph to 3/4, which is right here, so you should only see another half of a wave, which means go down to the minimum and back to the midline. Okay, you are supposed to graph all the way to pi over 8, and pi over 8 is just one tick mark over. So if one tick mark on the left is just to the minimum, then one tick mark to the right is just going to be to the maximum. And there you go. Now, it's not likely that we're going to put a very squinched up, small, tiny graph on the test. But if you can do that one, then you can for sure do one that's a lot easier. Okay, let's go to this one. On number 10, there is no vertical shift, and the amplitude is 3.5, so I'm going to go my midline, 1, 2, 3.5, and 1, 2, 3.5. Okay. I need to figure out the period of my wave. 2 pi divided by b, which is 2/7. Dividing by 2/7 is the same thing as multiplying by 7 over 2. And in this case, the 2's cancel each other out, or you can say 14 pi over 2, and 14 divided by 2 is 7. Either way, you get that the period is 7 pi. Okay, so I've got a negative cosine wave for my function. So I'm going to draw, just kidding. I'm going to draw a negative cosine wave and label the end as 7 pi. Okay? Now, 1 tick mark is 7 pi over 2, which, if you think about it, means it's half of 7 pi, which means that's 7 pi. And if that's 7 pi, then that means that is 14 pi. And I am supposed to graph from 0 to 14 pi. Okay? So, I know that a full wave is going to be completed by the time I hit 7 pi, which means I'm going to start at the minimum at 0. I should end at the minimum at 7 pi. I should max out at 7 pi over 2. And I should cross halfway between those two. Now, like I said before, you actually need to draw a point here to ensure that you actually go through a semblance of the center. And so there's that wave. Now we also need to go through we need to graph all the way to 14 pi, right? So I basically just graph it again. Okay. And there's my wave. Now, I'm okay with, like, this, I do that a lot to make them go like that. But what I don't like is when people do, I shouldn't do that, but, oh well. I don't like it when people do something like this. They're like, you go out too far. And then it's when you're not paying attention, you're like, something like that. Well, the white doesn't do that. That doesn't pass the vertical line test. So make sure that you don't go out past this point when you're going towards it, okay? That was kind of exaggerated, but some people are kind of wonky about their graphs. I've also seen some graphs that were more slanted than they should be. Okay, that's not like that. So just be careful on how you graph. Okay. On 11 through 14, what we're doing is we're writing a function that satisfies the given conditions. So y equals. There is it is a sine wave. There is a vertical shift up there of 3, so plus 3. I'm going to go ahead and, I'll just go ahead and finish the one. There's no amplitude. There's no obvious, it doesn't say amplitude, doesn't say any kind of reflection, but it does say that the period is 6 pi over 5. So I know that the formula for period is 2 pi over b, which equals 6 pi over 5. And this will allow me to solve for the number in front of x right there. Okay? So in order to solve this, I'm going to multiply both sides by b. And then I get 2 pi equals 6 pi over 5b. I want to solve for b, which means I want to get rid of 6 pi over 5. So I'm going to multiply both sides by the reciprocal, because you don't want to say divided by 6 pi over 5. But you can, as long as you remember that all that means is to multiply by the reciprocal. The opposite of dividing by 5 is to multiply by 5. The opposite of multiplying by 6 pi is to divide by 6 pi. Okay, those cancel each other out. Pi's cancel each other out. 2 and 6 simplify down to 1/3. And so all you're left with is a 5 divided by 3 equals b. b equals 5/3, so 5/3 x. I have seen some of this. Some people are writing this, and it looks like the x is in the denominator. Even if you write it like this, I mean, that's kind of scarily looking like it's in the denominator. I also don't like this, 5/3 x, because that also looks like x is in the denominator. So I would prefer either you write it as that or you write it as that. Okay? Okay. So on number 12. It is a cosine wave, so I'm going to go ahead and write cosine. It is an amplitude of 3.8. Is a vertical shift of 9. And then it's been reflected over the x-axis, which makes it negative. And the period is 17 pi. So 2 pi over b equals the period 17 pi. I'm going to multiply by b on both sides. Those cancel out. 2 pi equals 17 pi b. You want to solve for b, which is right now being multiplied by 17 pi. So divide by 17 pi. So the pi's cancel out. B is 2/17. So 2x over 17 or 2/17 x. Okay. Number 13. We've got a cosine wave with an amplitude of 5/7. There's a vertical shift of 4, and the period is pi over 9. I don't know what I was writing right there. So 2 pi over b equals pi over 9. Multiply both sides by b. We cancel out. If you know a shortcut to solving these, or if you know, like, you have a certain way of solving, solve it that way. It's perfectly fine. I'm just doing a method. 2 pi equals pi over 9b. So I multiply both sides by the reciprocal of pi over 9 to get rid of it. So I multiply by 9 over pi. 9 over pi. Pi's cancel out. 9 times 2 is 18. So b equals 18. So 18x. If you fail to put an x in the equation, it is gonna lose you a little bit of a point, because without an x, it's just a number. This is all just a number. It's not a function. Okay, so be careful. All right. For this one, we have a sine wave with an amplitude of 47.2 and a vertical shift of 131. And it tells me that the period is 8/3. Now, is it possible for the period to be anything other than something involving pi? Of course. A period can be a length of 2 units. It doesn't have to be 2 pi units, okay? So don't be weirded out if the period does not have a pi in it. Which means that when I do this, there's no pi, there's not going to be cancellation of pi, which means your equation is going to have pi in it, and that's perfectly fine. So I multiply by b. Let's cancel out. 2 pi equals 8/3 b. You want to get b by itself, which means you want to get rid of 8/3. So the opposite of multiplying by 8 is to divide by 8. The opposite of dividing by 3 is to multiply by 3. So I'm going to multiply by 3/8. Let's cancel out. 2 and 8 simplified on a 1 and 4. If you go ahead and do 6/8, that's fine, but it's got to be simplified. So it's 3 pi over 4 equals b. So 3 pi over 4x. And there's my equation. Okay? Alright. On number... So a whole bunch of the same things. This is yours. Yes. Okay. All right. Here we go. On number 15, it says, and number 15's numbers 15 through 18. It says determine the sine or cosine function with a given graph. Okay. Piece of advice. The first thing I do when I'm trying to figure out these is go ahead and graph or plot the point where it starts on the y-axis. And the fact that it starts up here, goes down, and then it comes up, makes me believe that that is my maximum. Just halfway between 7 and 8, so I'm going to go 7.5. And it looks like my minimum is at 0.5. But by drawing my starting point, I can quickly go ahead and decide whether or not it's a sine or cosine. And the fact that it starts at the max leads me to believe that this is in fact a cosine function. Okay? And a positive cosine because I started with the max. Alright, the distance between the max and the min is 7. So I know that if I cut that in half, then I've got the amplitude. So 7 cut in half is 3.5. And you can either write it as 7 halves or you can write it as 3.5, doesn't really matter. But I know that if I go down 3.5 or if I go up 3.5 from my max or my min, then I can get my midline. So 0.5 plus 3.5 is at 4. So I know that my midline is at 4. Okay? So I can go ahead and fill in the fact that I know it's a amplitude of 3.5, a vertical shift of up 4, and then all I need to do at this point is figure out the period. Well, When I think about a positive cosine wave, it does this and it does that. And the distance between here, the max and the min, is a half of the wave. So if this right here is 3 pi, then that means this right here is 6 pi. So I know that the period equals 6 pi. But I need to use that to find b in my equation, so I'm going to write 2 pi divided by b equals 6 pi. And then I'm going to multiply by b. 2 pi equals 6 pi b. I need to divide by 6 pi to get b by itself. Pi's cancel out, and 2/6 simplifies down to 1/3. So b is 1/3. Okay? Alright, on number 16. Number 16, like I said, the first thing I'm going to do is draw a point where it meets the y-axis. And the fact that it starts at the minimum leads me to believe that this is a negative cosine wave. So it's a negative, and I'm going to have a cosine, leave some space for my amplitude, and go from there. Okay, I know that my max is at 6, and my min is at -8. And if I add the distance, or if I add 6 and 8 together, then I get the total distance, which is 14. Now if I take 14 and cut it in half, then I get my amplitude, which is 7. Okay, so what I know is that if I go 7 up from -8 or 7 down from 6, then I get to my midline. And so that means we're at -1. Now there is nothing wrong with you going down one, go up one, go down another one, go up another one, until you get down to the midline. If that's what you need to do in order to find it, or to check it, then go ahead. Okay. But once you draw your midline, it should be pretty obvious that it's pretty symmetrical. Okay, so my midline is at -1. So I already know that my amplitude is 7, and that my vertical shift was down 1. And the only thing I need to do now is figure out the period. So for that, what I suggest you do is start going along with the graph. Like if I start graphing this right here, I go along. Once I hit the bottom right there, I start repeating what I've already graphed. And once you start repeating yourself, you're starting the next wave, which means this is the end of the first wave, and the period is 3 pi over 2. We do not put 3 pi over 2 inside there. What we do is we set up the equation 2 pi over b equals 3 pi over 2, and solve. Okay? So if I want to solve that, I'm going to multiply both sides by b. B's cancel out, and I've got 2 pi equals 3 pi over 2b. I want to multiply by the reciprocal, 2 over 3 pi. 3 pi's and the 2's cancel each other out. These pi's cancel each other out, and then all I can do is multiply 2 times 2, and then divide it by 3, so that is 4/3. So 4/3 equals b, which means this is 4/3 x. Okay. Let's go to number 17. On number 17, I'm going to start where it hits the y-axis. And the fact that it starts in the center of the wave means it's a sine wave. And the fact that it goes up means it's a positive sine wave. Okay. I know that I start at the midline, which is 5. So I know that's up 5. And it looks like I go up to 8 and down to 2, which is 3 away, which means my amplitude is 3. And then I need to figure out the period of the wave. So if I start sketching the wave, I go until I hit the end of the wave, because once I do that, I'm repeating myself. So that means the period of the wave is pi over 12. So if one period equals pi over 12, then 2 pi over b equals pi over 12. Multiply both sides by b. 2 pi equals pi over 12b. And then multiply by the reciprocal of pi over 12, which is 12 over pi. So 12 over pi. Those cancel out. Pi's cancel out. 12 times 2 is 24. So this is 24x, or theta, doesn't matter. Okay, on number 18. On number 18, like I said, sketch a point where it hits the y-axis, and that looks like it hits at 2.5, or negative 2.5. And if I want to be sure about that, then I look at the max, and the max looks like it's at 2.5. The min looks like it's at negative 7.5. And if you add that distance, or the distance, you find the distance between them, you get 10. And negative 7.5. Okay. And half of 10 is 5. So if I go 5 down from 2.5, then that means I'm down at negative 2.5. And if I go 5 up from negative 7.5, I'm at negative 2.5. So in fact, that is my midline. And you can see that my wave went through that point right there, right? So as far as like the fact that I started at the center of the wave means it's a sine wave. The fact that I went down first means it's a negative sine wave. The fact that my midline is at negative 2.5 means I'd go down 2.5 at the end. And the distance between these is 10, cut in half is 5, so my amplitude is 5. And then I just need to figure out the period. Well, one wave, one negative sine wave, starts at the center, goes down, goes to the center, goes up, and then back to the center, and then I start repeating myself. So, that is my period. 2 pi over b equals 10 pi. Multiply by b. On both sides, those cancel out. 2 pi equals 10 pi b. I want to get the b by itself, so I divide by 10 pi. Those cancel out, pi's cancel out. 2 divided by 10 is 1/5. So this is 1/5 x. Okay. All right. On number 19, it says 19 and 20, find a sine or cosine function that satisfies the following conditions. Okay, it tells me that I have a maximum of 6 at 0. So I'm going to go, and I'm going to find a couple different answers to this. In fact, I might find more than a couple, just in case you have an oddball answer. So 1, 2, 3, 4, 5, 6. One thing that really helps on these is to go ahead and draw tick marks so that it's easier to count, and go ahead and label things. Don't just look at it and try and think that you're going to be able to see it without actually drawing and labeling things. Not to say that you can't, but it's not advisable. Max of 6 at x equals 0, so when x equals 0. And a min of 1. It does say max, so I'm going to go ahead and draw a dotted line because I know that's my amplitude. Actually, yeah, I was just kidding about finding extra ones on these. There's only one. There's only one main option. And then min at 1, so I'm going to go ahead and draw a dotted line there as well. And it says the minimum occurs at pi over 4. Now, does pi over 4 have to be right there? No, I could have drawn it right there, could have drawn it right there, could have drawn it right there, could have drawn it right there. But it's pretty easy if I just give myself some space and then just label it and draw my dot. Okay? Now, the goal is always to pick the easiest way to get from that point to that point using a sine or cosine wave, okay? And if I think about my 4 options, I've got a positive sine wave, I've got a negative sine wave, I've got a positive cosine wave, and a negative cosine wave. And when I think about something that starts with a max and then goes to a minimum, it's definitely going to be the cosine wave. Which means I need to start at, well, it'd be easier if I just go and do this. That length right there is 5, between 1 and 6, and half of 5 is 2.5. Now, 2.5 up from 1 is 2.5. that means my midline is at 3.5. Okay? And so I know that my cosine wave looks like this. Okay? Basically, all you're trying to do is glean information. You know it's a positive cosine wave. We now know the midline. We know the amplitude. And the only thing I need to know now is the period. And if I look at my cosine wave, I know that this much to go from max to min is half of the wave. So both basically just multiply that times 2, and you get the full wave, and that's pi over 2. So period equals pi over 2. I need to write an equation. So y equals, it's a positive cosine wave with an amplitude of 2.5 with a vertical shift of 3.5 and a period of pi over 2. So 2 pi over b equals pi over 2. Multiply by b. Oops. Multiply by b. Those cancel out. 2 pi equals pi over 2b. Multiply by the reciprocal of pi over 2, which is 2 over pi. Pi's cancel out. And we're just left with 2 times 2, which is 4. So 4x. And there's my function. Okay. On the next one. I give you that you have a maximum of, a minimum of negative 8 at negative 3 pi. So 1, 2, 3, 4, 5, 6, 7, 8. And that is going to be at negative 3 pi, so I'm just going to kind of label negative 3 pi minimum. And then I have a maximum of 4 at positive 3 pi. So I know that's negative 8, and 1, 2, 3, 4 is where my max occurs. And it happens at 3 pi. So if I put negative 3 pi over there, then positive 3 pi should be, it's not quite symmetrical, but it will. Okay. So what I know is that my max doesn't occur at the y-axis, not unless I drew a bunch of waves in here, but that's not the goal. The goal is to always to graph the easiest way to get between these. Now, if I think about the distance right here, the distance between 4 and negative 8 is 12. And half of that is 6. So if I go down 6, 1, 2, 3, 4, 5, 6, I get at negative 2, which means my midline is at negative 2. And then if I think about just how to graph between these, it would mean minimum going to maximum. Okay? Which means I would cross right here because they're symmetrical. It's symmetrical on both sides. So then I've got my max here, and I've got my min there. And when I think about what kind of wave this is, well, I think about where did I start on the y-axis? I started at the midline, which implies a sine wave, and then it went up, which implies a positive sine wave. The total distance between max and min was 12, half of that was 6, so my amplitude is 6. And my midline ended up being at negative 2, which means my vertical shift is down 2. As far as the period goes, think about a positive sine wave, and then think about how much of the wave it is to just go from the beginning to the max. And that is only a fourth of your wave. Now you could, if you wanted to say, well, if that's 3 pi, then that's 6 pi, that's 9 pi, and that's 12 pi, so just keep adding 3 pi. Or you can just say 3 pi is only a fourth of it, so multiply it times 4, and you get 12 pi as your period. So 2 pi over b equals 12 pi, and multiply by b. Two pi equals 12 pi b, divide by 12 pi. Pi's cancel out, 2/12 is 1/6. So you can just do x over 6 or 1/6 x, doesn't really matter. Okay. On number 21, The directions for this one say find two different functions that satisfy the following conditions, and they're, the information that they give you is a little bit more, what am I trying to say? You're not tied down to one specific type of graph or one specific situation. And you weren't on the others either. You could have, but really all it would have done is just, if you'd drawn more waves between them, it would have just been a little bit uglier. So this first one, it says starts at 0, -4. So I'm going to go 1, 2, 3, 4. Plot a point. And it says minimum at pi over 2, -9. So I'm gonna go down to -9. 5, 6, 7, 8, 9. And I know that's my minimum. And then I know that the minimum has to occur at pi over 2. Okay. Now, what I like to ask people is, hey, is -4 the max? And then if you can't tell me because the directions didn't tell you, then that means something. It doesn't have to be the max, but could it? Sure. Is -4 the midline? It doesn't have to be, but could it? Yes. So when I think about my 4 options as far as my graphs go, what I want to do is I want to think about the ones that start somewhere and then go down to a minimum. So that right there is that. Negative sine wave, positive cosine wave, negative cosine wave. Okay. So when I think about which ones start somewhere and go down, this one starts somewhere and goes up. Does that mean it's not possible? No, but we'll do that one last. That's going to be my third option. This one starts somewhere and goes down, and there's the minimum right there, right? So I can make that work. That means this is the midline. And when I sketch it, I just draw this. And if I were to continue to sketch just to kind of see what's going on, then it does something like this. And so you can see the negative sine wave, okay? So let's get some information about that. That means my midline is -4. So I'm going to go down 4. I know that my amplitude, the distance between these two, is 5. And I can figure out my period. Well, I know that a quarter of it is a half pi, which means this right here is pi, which means this right here is 2 pi. So if half of it is pi, then the whole thing is 2 pi. Or if you know a quarter of it, just say a quarter times 4. And anytime you know the quarter of the wave multiplied by 4, you got it. 4 divided by 2 is 2, so the period is 2 pi. So if I try to solve the equation 2 pi over b equals 2 pi, well, you could go ahead and just multiply both sides by b and then divide by 2 pi. But it all cancels out. It doesn't mean b is 0, it just means b is 1. Something divided by itself is 1. And you don't have to write the 1. Okay? So now let's do it again, because it says come up with 2. I'm going to give myself a little bit more space. I didn't have to figure out how high I went up there in order to know what the graph is. All I got to know is the amplitude and the midline, and you can do that just by using half of it. Okay? All right. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I need to start at -4, and I need to min out at -9 at pi over 2. So when I look at my other options, I've already used this. This one does start somewhere and go to the minimum, so I'm probably going to use that one next. This one starts somewhere and goes up, so, I mean, unless I want to, no, can't do it. Can't, because I would have to start at the minimum there, so that's just out. Okay, so if I want to graph a cosine wave, well then I know that it has to start at, this has to be at the maximum now, because 4 has to be that point right there. And then I have to have my minimum right there, which means I need my midline. So when I think about the distance between -4 and -9, I know that it's a positive distance of 5. And half of 5 is 2.5, which means 1, 2.5, which puts my midline at 2.5 past negative 4, which is negative 6.5. Okay? If I were to sketch my cosine wave, I know it would do this, and then do that. Okay? So, I've got y equals, my amplitude is 2.5. It's a positive cosine wave with a midline at negative 6.5. And then I need to figure out the period. Well, when you think about your cosine wave, from max to min, that is half of your wave. So if half is pi over 2, then that means the whole wave is just times 2, and my period is pi. So 2 pi over b equals just pi, multiplied by b, and then divide by pi. And pi's cancel out, b is 2. And there you go. Okay, I did say I was going to show you a third one. The positive sine wave you can do, and basically what it would do is I'll just go ahead and sketch it. Because some people saw this one first, and that's okay. 5, 6, 7, 8, 9. But it's not one of the easiest ones to go to. But it's possible. So if you draw, I'm going to draw a little bit further out here. So I had some people that did this. They were like, okay, well, I'm going to make that my midline, and that's going to be my minimum, which means I'm going to have to go max, and then min, and then end. But the conundrum that you find yourself in is, well, what's the end of the wave? What's the period of the wave, right? And so what I would say is, well, think about this. In a positive sine wave, if you think about a fourth of the wave, like that's a fourth of the wave. That's 2/4 of the wave to get to there. That's 3/4 of the wave, and that's 4/4 of the wave. So this right here is pi over 2 in this case. Well, what I can see is that pi over 2 can then be split evenly 3 ways. So if I divide pi over 2 by 3, and dividing by 3 is the same thing as multiplying by 1/3, then that means that 1/4 of the wave is 1/6. And if that's 1/6, then what I can do is just count by 6. So that's 1/6, 2/6, 3/6, 4/6, which equals 2/3. So you could do a positive sine wave, y equals positive sine. Your midline is negative 4, and your amplitude is 5. The distance right there is 5. And if your period is 2 pi over 3, then 2 pi over b equals 2 pi over 3. That makes it pretty obvious. B is 3. But if you didn't, if you multiply by b, then 2 pi equals 2 pi over 3b, multiply by 3 over 2 pi. This cancels out, this cancels out, b is still there, pi's cancel out, 2's cancel out, b is 3. And there you go. Which is kind of interesting. It's not the most obvious, and it's not the one that I would go straight to, but it's an option. So all you gotta do is, if you know 3/4 of the wave, divide it by 3, so you can find 1/4 of the wave, and then multiply that times 4 to get that is another option. You can just multiply that times 4 to get the end of the wave. Okay. Let's do number 22. So number 22, you start at 0, 4. So 1, 2, 3, 4. You end at 4 pi 4. So there's 4 pi. And there end. Okay. There are a lot of different options for, well, no, there's not a lot. There's 4. I'll just draw some of them on here. You have an amplitude of 5. Yeah? Okay, so you have a choice. You can either decide, do I want to make sine waves, cosine waves, or one of both? Okay? If you think about sine waves start at the midline, which means this is my midline. Okay? If that's your midline and that's your beginning and that's your end, then that means halfway through you got to be at the midline. And if your amplitude is 5, that means I'm going to go down 1, 2, 3, 4, 5 to negative 1, and then up 1, 2, 3, 4, 5 to 9. And I can graph, well, at this point, does it matter if I graph a positive or negative sine wave? And the answer is no. Because if you graph a positive sine wave, the answer is perfectly fine. And if you graph a negative sine wave, it's also fine. So I can start here, max out at 9 halfway through, go to the middle, min out at negative 1 halfway through, and then go through there. So there's one option. Make sure you actually go down. I had to keep going because I didn't go down far enough. Okay. Okay, so the equation for that one is y equals, it's a positive sine wave with an amplitude of 5 and a midline of 4, and my period is 4 pi. 2 pi over b equals 4 pi. And that's by b. And 2 pi equals 4 pi divided by b divided by 4 pi. And you get 1/2. X divided by 2. Okay. You know what's going to stay the same every time? The fact that the period is 4 pi. So no matter what equation you write, it's going to be x over 2 on the inside. And the amplitude should always be 5. So the only thing that could possibly change is whether or not it's a sine or a cosine, and then where your midline is. So if I had said instead of a positive sine wave, if I had drawn a negative sine wave, it would have been just as valid. And the only thing that changes is the sign in the front. So I could have written y equals, and that can be your second one, negative 5 sine of x over 2 plus 4. But you could also draw cosine waves. So a lot of people didn't see this, or people didn't see this one as much. But if I start at 0, 4, and I end at 4 pi 4, with an amplitude of 5. So if you think about a sine or a cosine function starts at its max, just like this right here. It starts at its max, goes down, and then goes back up to its max. So that would mean we're making these two maxes. Now, the fact that your amplitude needs to be 5 would mean that you need to go down 5 to get to your midline and 5 more to get to your minimum. Or go down 10 to get all the way down to your minimum. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which puts you at negative 6. So if you let that be your max and that be your min, then halfway through you should be at your minimum, max, quarter of the way, 3/4 of the way. And there is, oh, just kidding, Jennifer. Your midline is not at the x-axis. It's down here. So, and there you go. Remember, this distance is 10, so then your midline should be 5 down from 4, which puts you at negative 1, or 5 up from negative 6. Okay, so if I write my equation, then that is a y equals, the amplitude is 5, it's a positive cosine wave, the period is 4 pi, so it's still x divided by 2, but my midline is at negative 1. Okay, but the other option is instead of drawing a positive cosine wave, I could draw a negative cosine wave. So let's sketch that. A negative cosine wave starts at the minimum, goes up, and then ends at the minimum, which means if I go all the way up 10 from my minimum, if this is my minimum, 1, 2, 3, 4, 5, 5 up from that makes it 9, which means 9 is my midline. 1, 2, 3, 4, 5, which puts me at 14, and that is my max, and that is my min. Halfway through I should be at the max. Cross it 4 3/4 of the way, and there is a negative cosine wave with an amplitude of 5 that starts here, ends there, with a period of 4 pi. And so y equals a negative 5 cosine of x over 2 with a vertical shift of 9. Okay? Lots of different options for something that starts here, ends there, and just has an amplitude. Okay, so last question. A tsunami approaches San Francisco Bay, which is a bad thing, but the water first goes down from its normal level. Okay, so I'm just going to kind of like sketch. Normal level. First goes down, then rises, I should probably say, an equal distance above its normal level. And then finally returns to its normal level, which leads me to believe that this is a sine wave, okay? A negative sine wave. So if I were to just kind of sketch, and I'm going to draw a line right here, but keep in mind that this is my midline and this is normal level, okay? So I'm just going to kind of draw amplitude lines that are kind of equidistant. That's not really, it's a negative. And then there is my sine wave. Yeah? Now I'm going to figure out what these numbers mean to me as far as this situation goes. Okay. The tsunami that is approaching has an amplitude of 12 meters, which tells me that this right here is 12 and that this right here is 12. So I already know y equals a negative 12 sine wave. And then it says the period is about 15 minutes, so that tells me that that is 15 minutes. So 2 pi over b equals 15. Multiply by b. 2 pi equals 15b. Divide by 15. So I've got 2 pi over 15x. Okay? And then the only thing I need to do now is read the rest of the problem and see what that tells me. The normal depth of the water at the San Francisco Bay is 12 meters. Okay, they're telling me that the normal depth, or the normal level, if you would, of the water is 12 meters, which means this right here is at 12. If that is at 12, and my amplitude is 12, it means going down 12, that is my x-axis, which puts me at 0, and that is at 24. Okay, which means my midline is positive 12. So my vertical shift is plus 12. Okay, I hope this helps, and if you have more questions or more concerns about your ability to just go through anything, please come in the morning and see one of us, and we will help you. Okay, good luck. See you tomorrow.